Can I just?
Thank you.
No, not that one. Just minimize it. Is the button next to it?
This one?
That one.
This one?
Yeah. I'll have to stay.
Okay. Yeah. I will do a short presentation about the use of this parallel workspace made by Morten and Bill, isolates and futures. I must admit that we haven't spent that much time. We have spent the last month or two to play around a little. But it looks promising, I would say. And what was our motivation for use these features? Today, our system, most of you know me, I have actually skipped our general presentation of SimCorp, but we are about 200 developers doing APL code. We have, how much is it? 1.7 million lines of APL code in many functions, over 70,000 functions. So it's a huge system that has been built since the past 20 years. I think the core of our system is about 20 years old, and then we'll build on top of that. And 20 years ago, we were not thinking about parallelization and functional programming as such. So it's a bit of a challenge to try to squeeze our system into this parallel universe. But of course, we have heavy calculations in our system, and we have built a load balancing server system a long time ago. So you can just add machines and ask them to share this calculation, and so we already have a kind of parallelization system, but it requires that you actually build your part of the system in a special way. So you cannot just take anything and say go and run it on a calculation server. You have to prepare the part of the system to actually be able to do so. And to hit the right button. And we do not actually have these single line, a lot of data crunching kind of functionality where we could really benefit from just parallelize it and collect the data, and then we could speed up things like that. Unfortunately, we are somewhere in between. Of course, we have things we do that takes too long time, things for our customers at least. But it's still a bit complex, and it could be a need for database access and all these kind of things. So it's a bit tricky. But of course, we have several of things where things go too slow. Maybe some of you were in Sicily and saw Morten's and my presentation about isolates. I don't know about external workspaces. And this is the way that Morten used to present how isolates should look like. You have a ordinary workspace, and then you could add a bunch of isolates and do some minor stuff there, and get back to your workspace. So this is Morten's version of where to use and how to use isolates. but as said in the beginning, this is not quite the SimCorp world, how we see it, because everything is very much entangled. It's we don't have these small bits and pieces that we could benefit from parallelization. So this is pretty much the way we would like to see the world, if it should be easy at least. Otherwise we have to rewrite our entire system. And 20 years of development is not something you rewrite overnight. So we more think about in the concept of worker bees, to send out requests that know about our system and are able to do stuff and then send back the results. I hope it makes sense. However, isolates, our system is a very database heavy system. It's built upon a database, and there's a lot of functions that look up in the database to get key figures, whatever, all kinds of figures used for specific calculations. And this is not really doable from within an isolate, at least what I have experienced so far. We have different global caches with data that is built up over time, and other variable state variables. So to actually use this from isolates, you have to think of call back to the main workspace. So you actually send out a job, and then it has to look back, and then suddenly things get a little complicated. But this is actually what we need to deal with, to have this kind of approach. Once started to look at this, one of the first experiences, a very important point to this approach is actually this is make use of this new external workspace concept. So we can actually store what's inside the main workspace. We can save as an external workspace file, and then simply attach it to the isolate workspaces, and then it reuses the same memory. So we will not have a huge memory footprint. We will not. So this is actually the reason for this external workspace concept from our point of view, to make this possible at all, to have such huge isolates. So once we fired up one of these isolates, attached the external workspace, I found that the isolate itself is actually a namespace within the workspace that is made. So the big green thing here is where all our functions are, and this small isolate namespace is where the things are executed. That makes it a bit difficult to work with, but for example, if we make a bunch of isolates, I have 4 CPUs on my machine, so I make 4 isolates and persisting isolates. And for example, we have a function called xvar, looking pretty much like this in our external workspace, but as you can see, it's not in the workspace of the isolate. The function doesn't exist, so you have to look up in the parent workspace actually to see the function. And when you call it, you have to actually encapsulate it like this. So It's unfortunate it's not out of the box like this is what you would have expected to do. But this requires the function to be inside the namespace and not the root workspace.
I would say that this is more a limitation of external workspaces than of isolates.
Yeah. I know that we actually not using it quite as it was expected. But nevertheless, the external workspaces idea from our point of view was actually to use it in this this way. So currently, this is the world we are dealing with, but we are still trying to see if we can get this worker bees idea up and running. But I would like to show you at least a little of
Stig, can I just ask?
Sure.
When you say external workspaces, are you referring to the DWX thing of putting code in external files, or is it just normal workspaces?
No, it's
Yeah, I think it's what was seen as DWX.
Right.
yeah,
The limitation here is that, I mean, that's still also experimental functionality. And at the moment, you can only attach an external workspace to hash. We don't yet have a mechanism where you can say, well, they attach this external workspace to a namespace and route it there.
Right.
And maybe maybe that's something we should have done. Maybe we'll do it in the future.
So it's a combination of two experimental models.
Yes.
Right.
And they don't quite mesh. But it's not that hard to work out.
well, I've been playing around with these for the past few weeks actually. We have been looking at this, and actually one of the problems have been to actually find obvious places to hook up with this isolate idea and to find suitable problems to try out. Where I'm sitting, maybe I should present myself a little more. I'm heading up the framework team that makes all the framework building blocks in APL. So all the GUI and all the different kind of things that that developers, business developers use to build their systems. So actually I don't know much about what our system does. I only know about the core part of the system. But I made a small function to make it easy to start up these, create the isolates and attach the external workspace. Actually, this function is not there yet. Bigger? Better? So yeah, I have to read the isolate workspace and then load some stuff. You can run in either debug mode or not. So if you run in debug mode, it actually launches the isolates as a single APL sessions where you can actually see when it crashes, you can actually work with the crash in this session. And to actually be able to make this loop back, where you had to set this listen configuration, and then you create the isolates. Maybe you should just start it up and And this function actually is the function that attaches the external workspace. So this is the iBeam. I was trying to set the path thing. It doesn't really help me. So here you see you have to wrap everything into a width block to actually go back to the workspace, the main workspace. That's the warning. Okay. And I had to use the result from all these isolates calls, because otherwise it returns you a future. If you just assign it to a variable, it's not necessarily completed after the call. So if I just make a bunch of calls into the isolate, it crashes at some point because it's not finished with the previous call. And so this is actually the reason why I made this rather stupid assignments here, simply to force it to run the isolate. So now we're actually up and running, and I never learned this fancy demo mode kind of stuff, but yeah, the usual. Auto, okay. Yeah. So running this delay function 4 times with a second, it takes 4 seconds, not very surprisingly. But running it inside the isolates. Oh, yeah.
Still takes 4 seconds, but
Yeah.
16 seconds.
So Lala, of course, not very useful. This is not. So okay, in my search for useful places where we actually see problems with regard to performance, and in very small scale, that is could be where isolates could help us to solve the problem, is dealing with these beats. So I made a vector of 8,000 floats, and I made it as taking 4,000 random floats, and then I take the same 4,000 and negate. So this will, of course, give you any suggestions? Roughly 0, yeah. So, and this is how things are with floats, and yeah, so you have to deal with it in some way. Maybe I should take my. Yeah. Of course, we have these decimals from dialog that could actually produce the correct result. So I use 128-bit decimal, and then I do the calculation. And to be sure to actually have the good old 645 typed floats back, I had to put it back to this type and just add a 0 to force it to demote to this type. If I didn't do so, make
remove the assignment to alpha. You're assigning it to alpha as a default. You want to.
Oh, yeah. Yeah, as you see, you get 24-bit, 128-bit back. Okay, but this is actually not something we use today. We have a function to deal with this. We can take any vector floats and it will eventually produce the right result. As you could see, it actually was a bit sticky. Took some time, but at least it gives you the right result. And we had to do all kinds of rounding. Actually, you had to take each number, add them up, and then round them according to the number of decimals in each number, and then take the next number. So, of course, it's very, very slow. So, let's do it with my isolates. So I simply split up my floats in 4 equal sized vectors, and then call this function, put in the parent namespace, and it produces a result. Of course, it produces 4 different sums, so basically this you have to add up the 4 numbers, and in this case it actually produces the right result, but of course we had to do it like this to be sure that we actually so this was just one example. Maybe I should take the
might be better for dialogue to multi-thread some of those deck-app operators.
Yeah, that could be. But as said, I really had a problem, so this is not the reason for us to start to using isolates, that's for sure. But at least it was an example of where it actually could make sense. So if we have it, we could probably use it, but so it definitely speed up things.
It's more than 4 times faster.
It's not producing the same result? Was it expected to?
It's not producing the same result.
Nope. The star on the second, the star at the beginning of the second row is CMPX telling you that it's didn't produce the same result.
Well,
It was much faster, so
but yeah, actually, somewhat. Oh yeah, I think it's actually because it's a vector here and a scalar here. So could it be the reason? So I definitely think it produced the same results. Another thing, another example I had is that we have to look up stuff in our repository. We store all our APL functions in DCF files, in component files actually, and sometimes you have to search through all the files to look for specific elements. Most things we actually have reference tables to look up, so we know which functions call which functions and where which global variables are used. We can look it up in tables. But for example, if we had to look up all places where the CT is called and assigned, and we want to make sure. Oh yeah, sorry. Okay. Yeah. So yeah, but this will look through all the files and to look, and it's a big system. There's a lot of functions, so you have to look up a lot of functions. So of course it takes some time, and let it run, and then I can do the same in an isolates way. So, as you perhaps saw, there were 4 different files we had to look up in, and okay, I can put it out in 4 different isolates, and do the same thing. It's simply just looking up in the files in the file system. So, of course, we have some problems with getting the data on the network, and you have to compete about the network bandwidth, stuff like that. So, but still, it's pretty much faster. It's still not finished over here. But we are finished. Now we're finished here too. So this is, of course, this is a development utility stuff. So this, but still, it's pretty much faster to do this way. Maybe there are some caches on the file server that helps me by starting out this one first and then this one secondly. So of course this is not necessarily the right picture, but just another example of where it actually would make sense. Unfortunately, we have asked the different business teams to find examples of, okay, when we do this kind of calculation, could we benefit from this? And we have had a few examples, but it has been really, really hard to get someone to give a very good example of where we could benefit. The problem?
The problem that we introduced load balancing many years ago. That's why you can't find proper examples for using this.
It could be, but still, load balancing is a very big, complex calculations that includes a heck of a lot of functions.
If you make a portfolio calculations on 10,000 positions, you can split it, and that's what you do in load balancing. You split them so that first example 1 on 1 CPU, etc.
Yeah, but, as soon as we have it up and running with the full-blown worker bees, we could do everything. So if we have to work with the database access, because there's quite a few functions that actually requires database access. So for now, what we have now at this point in time, we don't have these features, so it's hard to find actually examples. We had some examples with our auxiliary processors. We have a lot of calculations functions in a library where we do various data functions and all kinds of number crunching, and that it makes sense. Yes, we found some examples. So of course there are examples here and there. This is primarily to illustrate that actually it works, and it works within our system with the external workspace loaded. So I actually call the functions that's in our workspace, and it produces results. Yeah, sorry for my very old-fashioned way of okay. As said in the presentation, we have this function x_var that takes a Boolean vector and tells you where the truths are, where the ones are, and to run it using the isolates, it produces the same results as if we just did it this way. And is it always a good idea to run in parallel? You probably know the answer. Of course, let's take 10,000 elements.
Yeah. I'm pretty sure we can solve that problem with the hash somehow.
Yeah. So, not surprisingly, in this case, of course, it doesn't make sense. Just the point is, of course, you cannot just park your head and start using parallelization, and it requires, as Morten said, at least 100 milliseconds, and you have to move around a lot of data and to start up, even though they're persistent isolates in my case, so the isolate is actually up and running, but still moving the data around and doing the calculations.
I don't think you need 100 milliseconds. It's lower than that. But this is not.
No, this is definitely not a good idea. So, yeah.
This is taking 10 microseconds. Yeah. No, that won't work.
Yeah, as said many times, actually we have a problem in finding the obvious reason to start using this in big scale. And another problem is, as you might know, most of you, to find the time to do this kind of investigations and research and stuff, when we also have to build a system where we actually earn some money. But I'm no doubt that we can benefit from using this concept, but there's a lot of work ahead, but it looks promising, definitely. And we'll definitely wait for this to be a part of the APL interpreter. I guess still it's the idea to I don't know whether or what. At least for the moment, we have a problem with third-party APL workspaces and deploy this kind of things to our customers. Of course, if this is the only way we can get it, we will probably find ways to do it, but we'll definitely...
Yeah, no, we will find a way to bundle it so that it appears just to be there. I'm not sure we'll rewrite the pieces that are currently in APL because the analysis shows there's almost no benefit. If you're waiting for a TCP socket, little amount of APL processing time doesn't matter. So.
No, but
make it always present.
At least this is a minor thing compared to what kind of work we have to do to actually get it up and running full scale. But yeah, it looks very promising, and I said I probably didn't have to spend all my time, so we are almost on schedule. And actually, there's a lunch at 12 o'clock, but that's probably the worst time at all to go to the canteen. We'll eat in the canteen here. So if we go there 10 past, quarter past, probably much better, usually. So it's no problem if we go a little over time regarding the lunch. And when you get bored, there's these kind of things, pipe cleaners, what it's called. You can play very funny figures if you're bored. But yes.
Thank you.
Yeah, is it you, Steven?
Steven is next. We'll take a couple of minutes to hook him up. So if you want to take a quick break, stretch your legs.
På gæstenetværket her? Er det muligt for at komme på gæstenetværket?
Altså, der er wifi der, men der er faktisk også, der sidder bag skærmene, så er der faktisk en, du lige
Okay, jeg prøver den her.
This exercise, have you done this?
No, no, så du bare
Oh, yeah.